Alright guys, in this lesson we are going to address our final way of solving quadratics, and we're going to be using the quadratic formula. So as we work through this lesson, I want you to think about your essential question is explain how the discriminant, so that's a vocab word that we need to know, helps you determine the number of real solutions. So by the end of this lesson, we should be able to take these three equations and solve using the quadratic formula. Alright, so I just want you to take a minute and look at these three graphs. I have graph A, graph B, and graph C, and I want you to talk to me about how many solutions do you think each of those will have, and what are the solutions? So hopefully you're able to see that according to the graph, solutions are those x-intercepts. So this graph has two solutions because there's two places where it crosses, x equals 6 and x equals -2. This middle graph has no real solution because the vertex is below the x-axis and it opens down. So it has a maximum that will never reach the x-axis. And then this one has one solution because the graph just touches the x-axis. It doesn't actually cross it, and it touches specifically at x equals 3. So what happens if I have a graph where it doesn't cross exactly? So it's about -2.75 and about 0.6, but I can't tell exactly. So can we find the exact roots? Well, we obviously know we could graph it, but is there another way without the complication of the graphing calculator? So we have talked about different methods of solving quadratics, and we are going to land at our final one of solving a quadratic by the quadratic formula. And the benefit of the quadratic formula is that it always works. I can use it no matter what. I can only solve a quadratic by taking the square root if I don't have a b term. But I can always use the quadratic formula. So hopefully you remember from Algebra 1, the quadratic formula. So that was Talking Tom that helped us remember the quadratic formula. That is something that you should know. It is given to you on your TN Ready, the formula sheet. However, you should be memorized and know it from heart. So these are the guiding questions that I use as I'm solving using the quadratic formula. So the first question I ask myself is the equation set equal to 0. Why do we always want it set equal to 0? And we want it set equal to 0 because we're looking for the x-intercepts. And the x-intercept, y is 0 at that location. So my second question, what is a, b, and c? So I'm identifying the coefficient with the quadratic term, the linear term, and the constant. Then what is the quadratic formula? So x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. How do my numbers fit into the formula? So I'm just plugging the a's, the b's, and the c's in. And then how many solutions does the function have? And that comes from what we call the discriminant. We're going to talk about that in a minute. And then what are my solutions? All right, so I'm going to go through those guiding questions, and we are going to solve this quadratic formula. So my first question is always, is the quadratic set equal to 0? And in this case, it's set equal to y. And because I'm looking for when y equals 0, then I can basically just say that's equal to 0. All right, my next question is what is a, what is b, and what is c? So a is the coefficient in front of my squared term, so -1. B is my linear terms coefficient, so -8. And c is my constant, so in this case it is 12. All right, what is the quadratic formula? I always like to put all of my placeholders in place before I plug anything in. So I always like to write x equals the opposite of whatever b is plus or minus the square root of whatever b squared minus 4 times whatever a is times whatever c is all over 2 times whatever a is. And then how do my numbers fit into the quadratic equation? So opposite of b, so I'm going to plug in -8 plus or minus the square root of b squared, so -8, minus 4ac all over 2a. So my next question is, what is the discriminant? So from here, I'm going to simplify this. So the opposite of negative 8 is just positive 8, plus or minus, and then I'm going to find the discriminant. So the discriminant is the value underneath the square root sign. And so let's just take a second and step back and think about this. When I square root a positive number, I'm going to have that 8 plus the positive value and 8 minus that positive value. So if the discriminant is a positive value, I'm going to have two solutions. If the discriminant is 0, so the square root of 0 is 0, and any number plus 0 and anything number minus 0 is going to be the same value. So that's going to give me one solution. And then if the square root is negative, until later in this module, we can't square root negative numbers. So that automatically tells me if I get a negative value under here, I'm done and I say no real solutions for now until we learn about imaginary numbers. So right now what I'm going to do is I'm going to calculate the discriminant. So I'm going to type into my calculator negative 8 in parentheses because it's that value squared minus 4 times negative 1 times negative 12. When I plug that into the calculator, I get 16 as the discriminant. So that tells me I'm going to have two solutions. And then 2 times negative 1 is negative 2. All right, so what are my solutions? So we're going to solve this out. So I have 8 plus, and the square root of 16 is 4. So when I have a perfect square, I can go ahead and simplify it, divided by negative 2. And then my other option is 8 minus the square root of 16 divided by negative 2. So 8 plus 4 is 12 divided by negative 2 gives me negative 6. And then 8 minus 4 is 4 divided by negative 2 is negative 2. So my solutions for this are x equals negative 6 and negative 2. And I've included the graph down here so we can verify that those are correct. All right, so example 2, we're going to go through that same process. So is the equation set equal to 0? So I essentially want the y-intercept. So I want when y is equal to 0. So yes. What are my a, b, and c? So a, again, here is negative 1. B is negative 2. And c is negative 3. What's the quadratic formula? So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So now how do my numbers fit in? So b is negative 2. A is negative 1. C is negative 3. And a is negative 1. So my next question is how many solutions do I have? So I'm going to simplify this. So the opposite of negative 2 is 2. Plus or minus the square root. So in my calculator, I'm going to calculate that out. And I get negative 8 all over negative 2. And so a huge glaring issue that I have right now is that this square root sign has a negative under it. Because for what I know, I can't square root a negative number. So I'm going to go ahead and stop all my calculations. And my answer is no real solutions. And I'm verified by the fact that when I graph it, this never crosses the x-axis anywhere on it because it's the vertex is below the x-axis and it opens down. All right, in my next example, I'm going to go through that same process. So it is set equal to 0. A is 1, B is negative 6, and C is 9. So I'm going to plug those into the quadratic formula. So negative 6, 1, and 9, and 1. All right, so how many solutions do I have? I'm going to simplify this. So the opposite of negative 6 is 6, plus or minus the square root. And I'm going to square negative 6, subtract 4 times 1 times 9. And when I do that, I end up with 0 all over 2. And so I have 6 plus, and the square root of 0 is 0, divided by 2. And then I have 6 minus 0 divided by 2. Well, 6 plus 0 is 6, divided by 2 is 3, and 6 minus 0 is 6, divided by 2 is 3. So my solution is just x equals 3, and if you notice, that is verified by the graph below. So in the last 3 examples, I want you to analyze the quadratic equation for the no solution, the 1 solution, and the 2 solutions. When did we have no solution, when did we have 1 solution, and when did we have 2 solutions? So what conclusions can we make? So we call that value under the square root the discriminant. And that is essentially what determines the number of solutions. Because if we have a positive number under the discriminant, or under the square root, then we know we have 2 solutions. If we have 0 under the square root sign, we have 1 solution, because it doesn't matter, the square root of 0 is 0. And if we have a negative number, we know that we have no real solutions. So that can help us. It doesn't save us a ton of time. However, if we end up with this negative, we can see pretty quickly no real solutions and move on. All right, so we're going to do a couple more, a little more complicated ones. Those were pretty basic, just to get you used to an exact value format, because in Algebra 1, you were taught to just round, and now we're going to use the exact value. So if it's not a perfect square, we're going to use that square root sign. All right, so the first question, is it set equal to 0? No, it's not. So I'm going to move this 4 over to this side by subtracting. So I'm actually going to have 9r squared plus 4r minus 4 equals 0. So what is A, what is B, and what is C? And what is the quadratic formula? So I have x equals the opposite of B plus or minus the square root of b squared minus 4ac all over 2a. So b is 4, a is 9, c is negative 4, and 9. All right, so how many solutions do I have? The opposite of 4 is negative 4, plus or minus the square root. So I'm going to calculate my square root. And so I get 160, and that's all over 18. All right, so the square root of 160 is a decimal, so I cannot use that square root. So I'm going to go ahead and split it. However, I noticed that 160 is actually the same as the square root of 16, which is a perfect square, times the square root of 10. So when we have a square root sign, I can break it into 2 different pieces that still multiply together to get that. So 16 times 10 is 160. And I chose 16 because that's a perfect square. That's the largest perfect square that can go into 160. So the square root of 16 is really 4. So 4 root 10 is going to be the same as the square root of 160. So now I'm going to have negative 4 plus 4 root 10 divided by 18. I'm sorry, my pen is not working very well. And then I'm going to have negative 4 minus 4 root 10 over 18. And so I cannot put these together, because the root 10 is like a variable. So this is really like negative 4 plus 4 times this root 10. So I can't just put those together. And if you notice, my answer looks a little bit different. It's similar, but it's a little bit different. So I want you to look at my answer that is unfinished up here and down here, and see if you can figure out how we went from this to this and this to this. So hopefully you were able to see that I have a 4 plus a 4 root 10 and an 18 here. So when I think about negative 4, 4, and 18, I know that 2 can go into all of those. And so 2 goes into negative 4 2 times. That gives me negative 2. 2 goes into 4 2 times. And then I have my root 10 over, and 2 goes into 18 9 times. So that's how we ended up with this root. And then this one right here is going to be the same thing. 2 is going to go into those. 2 goes into -4 and -2 times. 2 goes into -4 and -2 times. Divided by 9. So x equals, those are my solutions. So this one is a little more complex, and I know the process was the same, but taking out the perfect square is something new, and then simplifying the numerator and the denominator was something that can go into both terms as well as the denominator. I know those are new things, but go ahead and write down just any questions that you have that you would want to ask about any process here. All right, so for example 5, I'd like you to pause the video, and I want you to solve it as far as you can get. All right, so hopefully you were at least able to get to this step right here. So plugging in A, B, and C into the quadratic formula, simplifying both this initial term and the discriminant, and simplifying the denominator. So if you got that far, go ahead and continue. All right, so I hope that you were able to figure out that the square root of 180 is not a perfect square, but it does have the perfect square of 36 in it. Now, if you did not get 36, my guess is maybe you got 9, because 9 does go into 180, but that leaves me with another perfect square of 4 coming out of 20. So 180 is really square root of 9 times the square root of 20, but then the square root of 20 has another perfect square in it. So you always want to go as big as you can. So starting with those large square roots, see if those go in evenly as you work your way down. So the square root of 36 times the square root of 5 is the same as the square root of 180. Square root of 36 is 6, so I took out that perfect square, and I'm left with the imperfect square, so I have this so far. And one of the things I noticed is I have -10, 6, and 10, so 2 can go into all of those. And that's where we get this solution right here of x equals -5 plus 3 root 5 over 5 and -5 minus 3 root 5 over 5. If you have those switched in order, that's okay. That means the same thing. All right, so I'd like you to think about this. What are 3 errors you think students tend to make when using the quadratic formula? What's something that makes sense to you? And what do you need to remember about the quadratic formula? So this is your reflection. All right, so our goal was to solve a quadratic equation by using the quadratic formula. Go ahead and have an interaction in your notes. What are you going to need to remember? What questions do you have? What are you going to need to talk about in your CSG tomorrow or next class? All right, guys, have a great night.